Hello, great thinkers. Welcome to another episode, another academic episode. Here we shall be talking about the circle. The circle. Generally, everyone knows the circle to be the locus of a point which moves such that it is always equidistant from a fixed point. Always equidistant from a fixed point. Okay, let's have that the fixed point is somewhere around the circle, just outside on the circumference. So the movable point, and the fixed point we're referring to is the center of the circle. That fixed point that will not move is the center of the circle, and the point that is movable, which is always equidistant, is the one that is moving on the circumference, this point here. And that equal distance we are referring to, that equal distance is the radius. So I repeat, that fixed point we are referring to is the center of the circle, usually labeled center O, and the fixed point is outside the circumference, on the circumference, and the equal distance is the radius. Having said that, let's proceed to the items we are going to see in the topic. We shall be looking at equation of a circle in radius center form. Also, we'll be looking at general form of the equation of a circle. Also, we'll be looking at the properties that we can observe from the equation. Points outside and inside a circle. We can also see internal and external contact of circles. Finally, we shall briefly see a brief overview of the parametric equation of a circle. That said, let's quickly proceed to the main thing, the equation of a circle. Alright, we consider here an xy plane, a Cartesian plane, and then we see a circle whose center here is labeled A, point A, coordinates A, B, while the point that moves around the circle is labeled P, coordinate XY. The radius, of course, R, and as we can see, the distance here is this distance is labeled Y minus B. That means the distance here is Y minus B. Also, as we can see, the distance here means the distance here is X minus A. Okay, this is a right angle triangle. So going by Pythagoras theorem, we can simply say that R squared, because that's the hypotenuse, equals to the square of the sum of the squares of the other two sides, that is Y minus B squared plus X minus B squared. What we just wrote is what we refer to as the simplest form, may I say, of the equation of a circle. So it means if we can express the equation of a circle in this form, then the number that is here, which is B squared, will be the radius of that circle. While we can have that the coordinates of the center will be seen in this place, that is A, B. I repeat, a circle with coordinates with coordinate of the center A, B. If the coordinates of the center are A, B, and the radius is R, then that circle will be written in that form. You can simply say X minus A plus Y minus B. Now, here's an example. Find the equation of a circle with center minus 4, minus 2, 4 and radius 5 units. From what we just said, we are using the equation x minus the x coordinate of the center. X coordinate of the center here is minus 2, so we can say x minus 2 squared plus y minus y coordinate of the center The y coordinate of the center here is 4. So that's y minus 4 equal to square of the radius. The radius here is 5, so 5 squared. If we have written it, square here, if we've written it this way, basically you've actually, okay, we have minus here. Let's write it. Let's simplify that to be x minus is x plus 2 squared plus y minus 4 squared equals to the square of 5. Actually, if we've written it this way, we've written the equation of the circle. But in a more simplified way, we might want to expand to make it look like how a normal so squaring this part of the equation, we have x squared plus, of course we can do that straight, plus 4x plus 4. Then squaring the other part of it, we've got plus y squared minus 8y plus 16 equals to 25. We've got to simplify. The equation of a circle is usually we collate the x squared part, the squared part, that's x squared plus y squared, then the x part, that is the 4x, then minus 8y, then bringing together this part, and this part to the other side, we have everything together equals to minus 5. Then we've got equal to 0 on the other hand. This gives us the equation of that circle that we're looking for. But before I go to another example, I want us to observe something. You must be very observant. If you are to learn mathematics, you must be very, very observant. If you look at the equation we wrote before, you see x minus the x coordinate of the center. That's x minus a squared. If a is the x coordinate of the center, and plus y minus b if b is the y coordinate of the center equals to square of the radius. You discover that if the center coincides with the origin where we have 0, 0, if the center of a circle, for instance, is like this, and the center of the circle finds itself on the radius, that means a will be equal to 0 and b equal to 0. Then this equation we have reduces to x squared plus y squared equals to r squared equals to r squared. So what we have here is basically, when we see, it's still the equation of a circle, but it simply means that the center finds itself, the center of the circle finds itself with the origin. It coincides with the origin. Okay, now let's proceed. Let's make progress. We've considered some example, an example. Here we want to consider another form. May I say here that we've got different forms, various forms of the equation of the forms, various forms of the equation. That is, we can be given different things for us to find the equation of a circle. Like we did in the first one, we were given the equation, we were given the radius and the center. We're given the radius and the center. But here we are given the coordinates of the center and the coordinates of another point on the circumference. Not the radius this time around. But that's just a step ahead of what we did earlier. I want to advise that in geometrical questions like this topic, always have a graphical sketch. If you don't have a sketch, at least you have to picture it. But to make it easier, draw it. Okay, for instance, let's have a circle somewhere here, whose center is 3, minus 4. 3, minus 4. and just some points on the circumference. It's just a sketch, do not mind, it's not drawn accurately. Some point on the circumference with coordinates -2, 2 here. If we can find the distance from here down here, that gives us the radius. Now, going back to our knowledge from straight lines, coordinates, geometry, we can find the distance in that around there by simply saying the square of the radius, that is, if this place is the radius, the distance, the square of that distance is the square of the difference between the coordinates of the x coordinates, that is 3 minus -2. We're going to square that, and the square of the y components, the y coordinates of the center and that other point there, we can say -4 minus 2, and square that. Then we simplify. This in the bracket here gives us 3 plus 2, that's 5. We're gonna have 5 squared plus this in the bracket here gives -6, and then we square that. Putting that together, 5 squared, that's 25, 6 squared, that's 31. Adding that together, we got 61, and that is the square of the radius. If you need the radius itself, of course, radius will give us the square root of 61, but sometimes we prefer to stop here because we're going to need the square of the radius itself later on. Now to the question. We have to find the equation. Don't forget that the equation of the equation itself is in the form, the equation that we're looking for, let me use another color here, is x minus the center, the x coordinate of the center, that is 3 in this form, x minus 3 squared plus y minus the y coordinates of the center, which is -4, and that gives us y plus 4. Square that equals to the square of the radius, and the square of the radius here is simply 61, so you don't have to you don't have to use this, but we can just use 61 straight up. And then, of course, like we did earlier, we may want to simplify for them to make it look more like an equation, and then we square that. Squaring this part, we got x squared minus 6x plus 9, and then squaring the other part, we've got y squared plus 8y, and then plus 16 equals 61. Of course, simplifying, rearranging it, we can have x squared plus y squared minus 6x plus 8y, putting the constant parts together, that is the 9, the 16, then the -61. When we bring it to the other side here, we've got minus 36 equals to 0. Okay, so this, what we've just written here, gives the equation of that circle. Alright. Here is another form the question can take. We can be given the coordinates of the endpoints of a diameter of the circle. We can be given the coordinates of the endpoints of the diameter of a particular diameter of the circle. Like we have in this question 3, PQ, which is the diameter, P is -4, 2, and Q -2, 2. We have to work out the equation of that circle, and as we have advised, we've always been doing, let's have a sketch somewhere here. Okay, so we can just say, of course, it's just a sketch. Let's have our P somewhere here. Let's have the P somewhere in that corner there. Let's have P somewhere here. P -4, 2, and of course, since it's a diameter, let's say it goes this way, and so the center is somewhere here, and point Q in the other end here. Okay, that's point Q. Alright, we're not given the center, but we can see that, of course, we know that the center is going to be halfway between P and Q. So basically we can just, to find the center, we can find the midpoint, the coordinates of the midpoint. We can find the coordinates of the midpoints of those two points there. So to find the coordinates of the center, that basically is we can add the x coordinates of P and Q, x coordinates of those points, that is -4, and adding it to 2 divided by we divide that by 2 to find the midpoint, and so that gives us the x coordinate. So we can say the x coordinate of the center is given this way, and then that gives us that's -2 there over 2, and that gives us -1. The y coordinates of the center, we do the same by adding up the two y coordinates together. That is 2 and 2 divided by 2, and that gives us 4 divided by 2, and that gives us 2. So it means the center now, the coordinates of the center is, let's say the center is O as usual, and that gives us, we can say the coordinates of O are -1, 2. Okay, so that's -1, 2. So we want to find the radius now. The radius, that is from here down here, the radius. Two ways, of course. Now that we have the center, you can simply find the distance between the center and any of the 2 points, either of the 2 points, or basically find the distance between P and Q and divide that by 2. So let's just go for one of them. Let's try to find the distance between O and any of the 2 points. Let's find the distance between O and any of the 2 points. That is PO, for instance. So if we have to find the distance PO, or no, let me find QO. The distance OQ, which is the radius, of course, is we can say the square of that is the square of the difference between the x coordinates, that is 2 minus -1 plus 2 minus 2, the y coordinates, the difference between the y coordinates, and we square that 2. So we add these 2 together, we got 3 there, we got 3 squared, plus we, of course, this is just 0 squared, so that's 9. That's the radius, of course, the square of the radius. So we can basically stop here, or if you like, find the radius to be the square root of that, and that's just 3. So the radius is 3, and the square of the radius is 9. Now the equation, back to the main equation that we want to find. To find the equation, that is x minus the x coordinate of the center, which is -1, so that gives -1, that gives +1 here. We'll square that, plus y minus the y coordinate of the center. The y coordinate of the center here is 2, so negative minus 2. We'll square that. 2 equals to the square of the radius. The square of the radius is basically 9 here, so we can just put that there. So expanding, we've got x squared plus the square of this, that gives x times 1. So we've got 2x there, 2x, plus we square this, we got 1. Do the same over here, we got y squared minus 4y, then the square of this last one here, we got plus 4 equals to 9. It's equal to 9. Okay, so rearranging to get the proper form of the equation, we got x squared plus y squared plus 2x minus 4y, then adding 1 plus 4, that's 5, then minus 9, that's minus 4. Minus 4 equals to 0. Equals to 0. So this gives the equation of the required equation